So we're going to talk about applications of arithmetic sequences today. And here I've got the formulas. The top one here, I'm going to circle this in red, is the formula for the recursive formula, which starts with the first term. You define a sub 1. You've got a sub n plus the common equals the common difference plus a sub n minus 1 means the previous term, the term before the one you're on. And there is this little tag for n is greater than or equal to 2, or sometimes for n greater than 1. It is implied that n is an integer, but that's just saying that you're looking at the second term. It's not, this formula does not help you find the first term. This one that I'm going to box in green here is the explicit formula, allows you to jump straight to any term. And then finally, we have the geometric sum formula. Or not the geometric sum, the arithmetic sum formula for a series. So we're going to use these to do a couple examples. They're pretty straightforward ones. So here we have the height of each step is 20 centimeters. The first step is 25 centimeters above the ground. How many steps would it take to climb to 205 centimeters above the ground? So this is going to be nice to use my explicit formula because I don't know which term I'm on. And I don't really feel like counting them up. 25 is my first, 20 is my common difference. So I'll subtract 25 from each side and get 180. And I'll distribute the 20. I'll add 20 to both sides then. And then I divide by 20 and I get 10. The 10th step is 205 centimeters above the ground. Pretty easy. The applications get a little harder, but they're not too bad. Let's look at example 2. It costs 20 zlotys for a plumber to come to your house, an additional 3 zlots for every hour the plumber spends on repairs. This is an international baccalaureate course. There will be lots of foreign currency. I have no idea which one this goes with. I suppose I could Google it. Feel free if you want. So write an expression for the plumber's visits that includes n hours of repairs. So cost $20 for the first hour. That's an a sub 1. Again, it asks me for n hours of repair. That's going to be a arithmetic sequence. Keep in mind that in your formula packet, this is right at the top of the first page. So first page, 20 plus 3. I don't have to pay the 3 for the first hour, so it is an n minus 1. We would probably simplify this, distribute 3, subtract 3 from 20, and get 17 plus 3n, or I think the book often writes it as 3n minus 17, which is probably more your normal order. Oh, nope. I did this wrong. I misread this. 20 to come to your house, $3 for every hour that the plumber spends on repairs. Gets rid of this minus 1. The first hour actually costs $23. 20 just for them to show up. Or you could write it in that other way. So it takes very important to read these carefully because they will put sometimes 20 is going to be the initial amount, sometimes it's 23, you got to add that in. Hence, calculate the total amount you'll pay for 5 hours. 20, so that's a sub 5 equals 20 plus 3 times 5. 35 zlots. I don't know, again, how to abbreviate that one. Okay, there's a lot more examples that are very similar. So we're going to skip ahead to example 6 here. Okay, you want to set the heating to come on before you get home. You know that the heat of your house temperature is 15 degrees Celsius and that on average, temperature rises 0.35 degrees Celsius for every minute the heat is on. Write an expression for U sub n. Oh yeah, we use U here instead of a lot, which represents the temperature that your house N is after you turn on the heat. I've used a lot of years, so it's taking me time to convert to U. But when they tell me what to use, U sub n, I need to use that. So this is a case where it starts at 15, okay? But after a minute, it is not 15 anymore. It is, goes up by 0.35. Okay. 15 is more like a U sub 0 term. Okay, so sometimes your sequence starts at, here's the first term. Sometimes it effectively starts at 0 or times 0. And then after 1 minute, we have U sub 1. Okay. So my expression here, I don't need the n minus 1. It's not 0.035, it's 0.35. N. Pretty straightforward. Hence, calculate how long it will take till your house gets warmed up to 21 degrees Celsius. I'll subtract 15 from both sides and get 6. I divide 6 by 0.35, and I get 17.1. My house will not have reached 8:21 and 17 minutes, so it is, it says hence calculate before it's approximately 21. I was going to say I'd have to round up to 18, but approximately 21 will be there in 17. That's going to be very close. Determine whether the model, so that again, keeping track of important words here, approximately means it's really close to 21, and I can just round correctly. If it said at least 21 degrees, I would have to round that up to 18 minutes. Determine whether the model is appropriate if you want to work out the temperature of your house if you leave the heat on for 5 hours. Well, 5 hours would be 300 minutes. Um, you guys may not know what room temperature is in Celsius, but it's approximately 25 Celsius. We're going to see how hot it would be if I kept this pace for 3 hours. Ooh, yeah, that's going to be a problem. It's 120 degrees Celsius. That's more than the boiling point of water. So, no, the model is not appropriate. Hopefully, if you have something that's an arithmetic sequence, you have it attached to a thermostat that shuts off when it reaches said temperature. So, this model might work for part of the time. That's a big thing in IB is we will see, it's a big thing in really all high-level math that we will see models that are realistic for a certain domain, not for a continuous domain forever. Okay, and that is the end of this lesson. You're welcome to look at more of the examples, but it's a lot more of the same thing.